Okay, continuing on in our section 2.5 session. Um, Now we just got finished doing the multiples of pi over 4. Now let's look at the multiples of pi over 6. Okay, of pi over 6. So there are tons of those. So draw yourself a big unit circle. And so here's our unit circle. Okay? And with our unit circle, again, we're going to start with 0. And then we have pi over 6. Now, this would be pi over 6. Pi over 6 is the same thing as 30 degrees. If you were to convert it back using our pi over 180 conversion factor, it would be 30 degrees. Well, what would 2 pi over 6 be? Well, 2 pi over 6 would be 30 more degrees since it's a multiple. 2 pi over 6 is the same thing as pi over 3, which is 60 degrees. Well, 3 pi over 6. 3 pi over 6 is right here. It's another 30 degrees. And it's the same thing as pi over 2, or 90 degrees. And we already know that. That's a quadrantal angle, so you don't really have to worry about that one. We've already got that one on our list. All right? The next one would be 4 pi over 6, which would be another 30 degrees. 4 pi over 6 reduces to 2 pi over 3, or 120 degrees. Another 30 degrees gives us 5 pi over 6, okay, 5 pi over 6, and of course that would be, if this is 120 degrees, then this would be 150 degrees. 6 pi over 6 is the same thing as pi. Well, luckily we already know that. That's a quadrantal angle, so that's 180. Then we have another 30 degrees, another 30 degrees, and this is 6 pi over 6 right here at pi, so this is going to be 7 pi over 6. This is going to be 8 pi over 6, or 4 pi over 3 when it's reduced. We're reducing these, remember. This one is going to be 9 pi over 6, but 9 pi over 6 reduces to 3 pi over 2. And we already have it. It's a quadrantal angle. Then we have another 30 degrees and another 30 degrees. So this is going to be 10 pi over 6, which is 5 pi over 3 when it's reduced. We have 11 pi over 6, and we have, of course, 2 pi at the end, or 12 pi over 6, okay, and that's a quadrantal angle. So here's our multiples of pi over 6. Now, you have to think about what we have here, okay, and we have essentially what we have is, if you look at the first quadrant, if we were to look at just this angle here, just this triangle here, so right triangle, okay, and with that right triangle, if we draw it off over here where everybody can see it, it looks like this. Okay, so this angle is 30 degrees. We've already discussed that. 30 degrees, as we see right here. Now, if this is 90 and this is 30, that means this is a 60-degree angle. So we have to use the 30, 60, 90 triangle rules, kind of like we used the 45, 45, 90 rules. Now, with this, we know with the 30, 60, 90 triangle, okay, like the one we have here in geometry, what we learned is that when you have a 30, 60, 90 triangle, that the hypotenuse if it's given like it is here, because we know what this hypotenuse is, we know it's 1 right here. The distance from the origin to any point on the circle, remember, is 1. So we know it's 1. The short side, this would be our short side right here. This would be the short side. The short side is going to be half, 1/2, the hypotenuse. The long side is going to be square root of 3 times the short side. Now, this is these are rules from geometry, so that's why I'm just giving them to you at this point. But that means if we know that this hypotenuse is 1, then what does the short side have to be? The short side has to be 1/2. 1/2 times the hypotenuse. Well, what does the long side have to be? Well, it's square root of 3 times the short side. So that's the square root of 3 all over 2. Square root of 3 over 2. So at this point, this is our 30, 60, 90 triangle. Now this is our y coordinate for this particular triangle. This is our x coordinate. Now you've got to be careful with this, okay? You've got to be very careful, because when we get ready to do pi over 3 here in just a moment, here's the difference in pi over 3. Let me redraw that. Here's the difference in pi over 3 and pi over 6. Notice the 60-degree angle is where the 30-degree angle is. So this would actually be our short side, and this would actually be our long side. So it's basically flipping our triangle, and I'll show you more about that because we're going to have one like that here in just a moment. And I'll show you more about that. So if we look at that, then we know that this right here would be our, this 1/2 would be our, this 1/2 would be our y coordinate, and I just erased everything I just wrote up there. This 1/2, if we look at this triangle that we had a 30, 60, 90, it was 1/2, 1, square root of 3 over 2. This 1/2 would be our y coordinate for this particular spot. So when you're looking at this angle, we're looking right here at this pi over 6 angle. This is that means our point is going to look like this. The square root of 3 over 2 is our x coordinate. So this is going to be square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. Okay? Now, by symmetry and reflection is how we're going to get the rest of these. So if you notice here, the next one would occur right here. And this would be pi over 3 actually. It's 2 pi over 6. But notice what it essentially is. What we have essentially done here is taken this triangle right here and we have flipped it like this. So right now this is 1/2, this is the square root of 3 over 2. Now this is the square root of 3 over 2. This is 1/2. Does that make sense? Because of the way we flipped it. Okay, so the point here is going to be 1/2 is our x coordinate, our left right. 1/2 is our x coordinate, and our north south y coordinate is going to be the square root of 3 over 2. Now remember, you're going to commit all these to memory, so it's a lot easier for you to do. So you're not going to have to go through all of this every time. Now once you have these two, you can pretty much get the rest of them from simple multiples. Okay, so right here we have 2 pi over 3. Right here we have 5 pi over 6. At this point we have 7 pi over 6 that we talked about earlier. At this point we have 4 pi over 3. Now remember, all these pi over 3s have been reduced from pi over 6. So the original pi over 3 was 2 pi over 6. Then we went 3 pi over 6 right here. 4 pi over 6 is how we got 2 pi over 3. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 is how we got 4 pi over 3. This would be our 3 pi over 2 here. We already know it's a quadrantal angle. Here's our next one. And it's going to be 5 pi over 3 after it's reduced. But it is a multiple of pi over 6 and pi over 3. Now what we're basically doing, I said these were multiples of pi over 6, which we started out doing them as multiples of pi over 6. But in the same light, we are also taking care of the multiples of pi over 3. Okay? The multiples of pi over 3. So this is actually us doing two things at one time here. Okay? So now, we have these two values to go on. Now, in the first quadrant, the x and y are positive. So as we move throughout the rest of this, and begin to write points on the rest of these, all the pi over 3s are going to have the same format, just like we did with our pi over 4s. The only difference is that the sign will change. So here, our x value is negative. So this is a negative 1/2 and a square root of 3 over 2. Okay, for 2 pi over 3. And then for 5 pi over 6, since x is negative, this is going to be a negative square root of 3 over 2 and a 1/2. Okay, does that make sense? Because it's in the second quadrant, the x coordinate's negative, but notice it's the same number, we're just adjusting the sign value based on what quadrant we are going into. Okay, so what would it be for 7 pi over 6? Well, since it's a pi over 6, and in quadrant 3, both of these are negative, it's going to be negative square root of 3 over 2, negative 1/2. Well, what would it be for 4 pi over 3? Well, here's our pi over 3 mark. Here's our pi over 3 mark. It's going to be a negative 1/2 and a negative square root of 3 over 2 because it's in the third quadrant. Keep that in mind. That's why we're getting, the values aren't changing, it's the negative signs that are changing. Okay? So pi over 3. Again, here's our pi over 3 mark. And in the fourth quadrant, the y value is negative. So this is going to be a positive 1/2, a negative square root of 3 over 2. Does that make sense? So this would be positive 1/2, negative square root of 3 over 2. Let me draw a better 2 there. Okay. And for our 11 pi over 6, same thing. The y value is negative, so we're going to get a square root of 3 over 2. The square root of 3 all over 2. And since the y value is negative, it's going to be a negative 1/2. Okay, a negative 1/2. Now, this covers the multiples, wow, pen's going crazy here. The multiples of pi over 3 and pi over 6. Okay, the multiples of pi over 3 and pi over 6. So if you go in your book, what you'll find on page, and this is what you need to commit to memory, page 102 in your book, at the top of the page, you will find the complete unit circle. Quadrantals, pi over 4, pi over 3, pi over 6, all on the same circle. Okay? Memorize that. Draw it, write it, go on the internet, search for, you can search free blank printable unit circles, and you can print off you as many sheets as you want and practice writing in these values. But you need to memorize that unit circle at the top of that page. Okay? So memorize that. The unit circle at the top of that page. Alright, so now that we know the unit circle, now that we have all the values determined on page 102, now we can very easily solve some problems. So let's look. Alright, so for instance, if I ask you what the sine of 7 pi over 6 is, well, you got to know where that is. Okay, so if we're looking at our unit circle, 7 pi over 6 is right here. Okay, so we're looking at this triangle here. Now, remember, it's a pi over 6. So all pi over 6 carry this form. All pi over 6s carry this form in some way or fashion. The only thing that is different is positive or negative. So at 7 pi over 6, it's in quadrant 3, so both of these are going to be negative. Okay? So now that you know that, well, what is the sign of it? Well, remember, the sign is the b value. So if this is A, this is B, negative 1/2 would be our answer. Okay, well, let's look at another one. What about the secant of negative 60 degrees? Oh me, we're in degrees. Where's negative 60? Well, think of your unit circle. We're going, instead of going counterclockwise, we're going clockwise this time. 60 degrees. So this is 60 degrees. That would be our negative 60 degree symbol right there. So what is in that value? What is 60 degrees from the x-axis? Well, hopefully, the first thing that pops in your mind, or as you're looking at your unit circle and memorizing it, 5 pi over 3. 5 pi over 3 is 60 degrees below the x-axis. So, or negative 60, for instance. So that would be 5 pi over 3. So, with pi over 3's, remember, all pi over 3's carry this particular form. Okay, all pi over 3's carry that particular form. The only thing different is the signs. So remember, in this quadrant 4, x values are positive, y values are negative. So that's a negative square root of 3 over 2. But this is secant. Now, if I'm doing this problem, the first thing I'm going to do is I'm going to figure out what the cosine of negative 60 degrees is. Well, cosine would be the a value, remember. So the cosine would be 1/2. Now this is secant. So what would the secant be? The secant would be the reciprocal of that, which is 2. Does that make sense? All right, let's try another one. Okay, so let's look at this one here. We have the tangent of 120 degrees. So where's 120 degrees? It is right here. So, having memorized this, that is 2 pi over 3. Okay, notice 120 degrees, that's 30 degrees past the y-axis, or if you're thinking in terms of the x-axis, it's 60 degrees above the x-axis. Okay, so 2 pi over 3. Now, pi over 3's, again, have what kind of form? They have this form. The only difference is that you have to determine, since it's in the second quadrant, what value is going to be negative. Well, it's going to be the x value. So this is my a, this is my b. Now remember, tangent is b over a. So this is actually going to be the square root of 3 over 2 divided by negative 1/2, which is the same thing as the square root of 3 over 2 times negative 2 over 1, which gives you negative square root of 3 for tangent. Okay, for tangent. So it's going to be very important. Now, when you're going in the negative direction, your goal is to find that negative angle, but what positive version is it coterminal with? This is where those coterminal angles are going to come in, because we don't have negative versions of the angles on the unit circle on page 102. All of them are the original out of 360 degrees regular positive angles. Okay, so when you go clockwise in the negative direction, this is where your knowledge of coterminal angles is going to have to come in. Negative 60 degrees, that's the same as what unit circle angle? It's the coterminal with what unit circle angle. That's how you're going to be good at these problems, okay? Well, I'll see you in the next video.